today I'm going to talk about some of the advances in the web platform over the last few years and how they helped our web application achieve infinite scaling and how it might be able to do the same for you. So first we'll be talking about client-server and client-only architectures. And then spoiler alert, we're going to be talking about WebAssembly. So what does WebAssembly let us do? What are some of the trade-offs? How you can get started in your own application? And then we'll deep dive into some examples. So first, client-server and client-only. So a client-server architecture has been around forever. That's how we've done our web applications. So you can see in this example, very simple. We're having our HTML, CSS, maybe some JavaScript. I mean, realistically, yes, it'll be JavaScript. And our user will fill out a form. They'll submit the form data, go to the server. Server will process it, send a response page back to the client. The client will redirect. So more and more after that, AJAX applications have become more common. So with an AJAX application, we're going to send HTML, JavaScript, and CSS. The user will do some stuff on the client. So they'll scroll to the bottom of the page to load more data. Maybe they're going to click a button that's going to transition to a different view. And then that's going to send a request to the server. Server will fetch that additional data. Client takes it, updates the DOM, and then we repeat. So as the user does more actions on the page, we're going to do the same thing, request to the server, get more information. So sometimes with our server applications, what we're going to be doing on the server is going to be a bit more intensive. So we might be compressing a file. We might be rendering a PDF page. We might be doing computation. So of course, this requires, as we get more users, we're going to need to scale up. So we're going to, it's going to cost us more money as we scale up our server and cost us more time to maintain that more complicated architecture. So it's also going to cost us time for our users. Our users have to wait for the network. It's going to be sending information back and forth. And you might tell me, Matt, there's serverless architectures. We don't need to worry about this. It's not that complicated. And that's a good point. But it doesn't solve every problem. It can simplify the architecture, but it's not a silver bullet, and it still does cost some money and time. So in general, client-server architectures, they work fine. For many applications, this might be what you need to use, depending on what you're doing. But with advances in the browser and what it's capable of, you might be able to do more. So just in general, browsers have been optimizing the performance of their JavaScript engines. So general JavaScript is getting faster and faster. The capabilities of the devices that people are using to access the browser, they're getting stronger. They're better, more RAM, more CPU, more cores. And then there's also new technology, so new capabilities for the browser. And that's what I'm going to be talking a bit more now about, specifically WebAssembly, where we can do client-side processing with actually very good, almost native performance. So quick example, what if we were able to cut out most or maybe all of our server processing? If we could do that, we could remove all of the latency for our users. Once the initial modules are loaded, we're not going back to the server anymore. So we're going to also simplify our architecture. So removing all of that server setup. And just a quick graph there, it's an example with AWS Lambda. As our requests increase per month, our costs obviously increase. And that's in US dollars for the y-axis. With the client, we're just needing a static server. The cost is effectively $0. So let's talk more about WebAssembly. And so how did it start? How did it come about? And with WebAssembly, first there was ASM.js. So with ASM.js, that came in around 2013. And so what it allowed was there were tools that could compile your code, your native code, into JavaScript. And it was a subset of JavaScript. So this would allow the browsers to make assumptions, make optimizations about what your code was doing. And the browsers created benchmarks. And then they started optimizing towards those benchmarks to make it faster and faster. We know how JavaScript can be kind of quirky with the dynamic kind of stuff that it does. So with these optimizations and those, the optimizations that you could do, it became a lot faster. And the bonus was that it was just JavaScript. So since it was just JavaScript, it just worked. It was backwards compatible, even if the browser wasn't optimizing specifically for ASM.js, it would still work. It would run in Internet Explorer, for example. Maybe not fast, but it would run Internet Explorer. At the same time, in 2013, Chrome introduced the portable native client, so called Pinnacle, short for Pinnacle. And with Pinnacle, it was kind of almost like a precursor to WebAssembly. Unfortunately for Chrome, they weren't able to convince any other browsers to implement it. So this meant that it never really took off. So yeah, shortly after WebAssembly was introduced, Pinnacle was discontinued. It didn't really have a good purpose anymore. So finally, that brings us to WebAssembly. So with WebAssembly, we have our code written in other languages, goes through our compiler tool, and it can execute on the web with near native speeds in a safe sandbox environment. And so the thing about WebAssembly that they made sure to do right from the start that Pinnacle did not do is that it was a collaboration with other browser vendors. So that made sure that all the browser vendors implemented it and the web developers could count on it being available. You can see from that quote on the right as well, it's not primarily intended to be written by hand. It's intended to go through a tool, usually. So what can we do with WebAssembly? What does it allow us to do? So we can take our existing mature code base that's well tested, we can run it through a compiler, and it can spit out a WebAssembly module that runs fast in the browser. So we can do this relatively quickly. So if I was going to say that WebAssembly didn't exist, I want to have some JavaScript, I want to bring my server processing into the client, I'd have to go and rewrite my JavaScript code. And that's going to take a lot of work, probably going to be buggy at first. And the performance at the end of the day is not going to be as good as what we get with WebAssembly. So WebAssembly, we have that tool, we can do it really fast. And it's going to run fast once we get there. So maybe you don't want to bring your entire application into WebAssembly, but you can boost the performance of specific parts and lower the server load of specific parts. So, and look for that, and then you can move that to WebAssembly as well. It's another option. You don't have to go all in. And that improved performance overall, it makes things that before, maybe they're impossible. Maybe they're impractical just because of performance. Now we can do them. Now we can do them in the browser. And so just overall, if you minimize the server interactions, it's just a simpler application, smaller security footprint. Those client-server interactions can be hotspots for security issues. More responsive for your users when you don't have to worry about the network latency. And for some situations, you can simplify your security policies. If you were uploading a file just so that you could do some server processing on it and then sending it right back to the client, you might not have to do that anymore. You could do it all in the browser. You can tell your users, this is safe. I'm not storing it. I'm not doing anything with that file. So here's an example of a PDF viewing application where the server is controlling the rendering. So we can see going back and forth, there's a lot of information going back and forth between the client and the server. So the client might request to render page 1. Server goes, parses the PDF, processes it, generates an image, sends it back. Client puts it in the DOM. Then the user says, I want the bookmarks and annotations. Sends that message to the server. Server processes the PDF, extracts the information, sends it back. The client then zooms into page 1. Server needs to generate a higher resolution image for page 1. So the user scrolls to page 2. We need to render page 2, and et cetera, going on and on. So all these actions require a server to do some extra work. You can imagine as we get more users, this is just one user, we're going to have to be thinking about our scaling for sure. This is server intensive. So what if we could use WebAssembly? What if we could simplify this whole application architecture where WebAssembly is doing the work instead of the server? And you can see we have this super simple architecture where the server sends HTML, JavaScript, CSS, WebAssembly, and then the WebAssembly handles everything. So JavaScript talks to the WebAssembly module, requests it to render pages, requests it for the bookmarks, annotations, any other data, and all of that's happening in the client. We don't hit the server anymore after this. So you can see how now we're achieving infinite scaling. And just to get you thinking, here's some examples of different applications that already exist where WebAssembly is being used. So you can see a wide variety of things here. So you can say, that's great. What's the catch? What are the trade-offs? So one of the things to consider is that on the server side, we're usually not trying to optimize every byte like we do on the client side. So your existing application that you're converting, you probably weren't thinking about how to make it as small as possible. So when you compile your WebAssembly module, you might be in for a little bit of a shock when you see the size of that file. So in a bit more of an extreme example, with LibreOffice, they have a sample page using WebAssembly. And if you look in the network tab, it's downloading about 90 megabytes of stuff. That's uncompressed, but it's pretty big. So not everything's going to be that big. Not every WebAssembly module is going to be that big, but it's not in the kilobytes usually, depending on what you're doing. So you can mitigate this somewhat. There's a thing called streaming compilation. So you can sort of download and instantiate the WebAssembly module at the same time in parallel. This can kind of mitigate it. You can also try to structure your application so that you preload the WebAssembly at the same time. So if the user maybe is interacting with other parts of your web app, at the beginning you start downloading and instantiating your WebAssembly. By the time they actually get to the part where they're using WebAssembly, it's already ready, it's already loaded. So you can try to structure your application to minimize that. So the other thing to consider, how are we getting this infinite scaling? Well, we're using the client's computing power, of course. So we need to consider who are our clients? Who are our users? And we need to think about, are they less powerful mobile devices? Maybe it's going to run a bit too slow. You want to test this for sure. Is it using more battery life than your users might be expecting or used to? Something to test, something to consider here, since it's using more of the client computing power instead of the server. And then as well, you want to think about what is the data that I'm operating on? Of course, if it's private information, if you don't want the client to access this information, you shouldn't send it to the browser so that WebAssembly accesses and tries to modify it. Even though it might seem like it's difficult to access, once it's in the browser, someone who's determined enough can use the web developer tools. They can go find your information. So how can we get started? If you wanted to migrate some of your application to a WebAssembly-based app, more client-side computing. So first I want to look at what are you currently doing on the server side that might be a good candidate. So a good candidate could be maybe file or data processing. So maybe you're compressing, optimizing, parsing, rendering, generating, computing, doing something with a file or something like that. There might be libraries that already exist. So I just listed a few here for video, audio editing, some advanced JSON processing, compression, PDF generation, and image processing, but there's many more. So you can look and see, maybe the library I'm using on the server side, maybe there already exists a WASM port of it. Maybe there's a WebAssembly library version that I can already use. But if there isn't, you can kind of look and see, maybe you can generate it yourself. So a popular tool for doing that is called Emscripten. You can look through that documentation there, but it's a simpler, relatively simple tool. Taking your server-side code spits out a WebAssembly module that can run in the browser. So it's something you can test out and see, can you do that yourself? Can you take that and use it in the browser? And so let's go a bit deeper into examples to see how this could work. So first I'll start with a kind of a more simple one. I was just looking around on GitHub. I found a repo called HTML5 Video Splitter. So HTML5 Video Splitter, it uses the library FFmpeg on the server side, and it splits a video. So you can see the architecture here. In general, the client's going to open the video, choose a video file from their computer. They're going to select a location where they want to split at. Then they're going to upload the video to the server and the location where they want to split. And then they're going to use FFmpeg on the server to split that video. Once they've split the video, they'll send it back to the client. And the client will get that data and they can download it, the split video. So you probably can't see it, but this is some of the code that they're using. It's just a Node, pretty simple application, Node.js server. Has a string there of the FFmpeg command it wants to run, and then it runs exec on it. So I wanted to take this code and see if I could migrate it to WebAssembly, see how difficult that would be, and see if I could make this application basically infinitely scale. So it turned out to be maybe easier than you think. This is some of the code that I wrote. So we're loading FFmpeg. You can see FFmpeg WASM. It's using the FFmpeg WASM library, so there's already a port of that library. FFmpeg sort of has a virtual file system when you're running in the browser, so we can take that file data from the file that these are selected, We'll write it to the virtual file system for FFmpeg, and then we'll see that FFmpeg run command. So you can see it actually looks very similar to what we're seeing on the server. So that string there almost corresponds exactly to what we're doing in the WebAssembly version. One gotcha, all the parameters are strings. If you pass a number, like I might have done, you get some weird errors. So basically, just make sure to do that for FFmpeg WASM. And then it's going to write that output to the virtual file system, and you can read that back. So that's the read file command. Turns it into a blob, and then we can use, I'm using a library called FileSaver with the save as function. We save the blob data, it goes to the user's computer. So here's our simplified, updated architecture. And you can see the server just sends the HTML, JavaScript, CSS, WebAssembly, and then it's done. It just sits there. The JavaScript and WebAssembly are now talking to each other. That's how they split the video, and then the WASM sends the split data back. So we're infinitely scaling now. We don't have to worry. We just have a static file server for the server. And it limits security concerns. The users don't have to worry, why am I uploading my file? It also takes time for them to upload their file and then download it again. Don't have to worry about that anymore. So again, like I kind of mentioned earlier, the size of the WebAssembly, you have to consider that. Uncompressed FFmpeg WASM is about 21 megabytes. So something to consider there. And you can use strategies like I talked about with preloading. So with, for example, this application, the user probably has to go, they're going to click the button, they're going to have to look on their computer for their file, their video file. It's going to take some time. So while that's going on in the background, we can be preloading our WebAssembly. So now a bit more deeper example with actually our Parizeau web viewer. So the Parizeau web viewer is for viewing and editing PDFs and Office files and other file types as well. And so our previous application, it actually required a server-side conversion. So we would do a server-side conversion of, say, the PDF file. We'd convert it to a simpler format. And then we would have our JavaScript code actually download and parse that simpler format. We'd be able to render it in the client. So at the same time, this was a bit complicated because the conversion time was hard to predict. For simple files, it was pretty fast, but for more complicated files, it was hard to predict how long it would take. So for more complicated files, it could be 30 seconds, it could be a minute. That's a long time for a user to wait for. That's not a great experience. So we already had a C++-based library that could render PDFs. What if we could take that library, convert it to WebAssembly, and process the document directly in the browser? We would just need, like we saw in the last example, we just need a static file server. So here's a basic diagram of how that application looked like, the architecture. So we'd send the HTML, JavaScript, CSS. The client would request a PDF to load. The server would convert that PDF to a simplified format. And then after that point, we're not really making the server do anything else. The JavaScript and web worker are talking to each other to render the page. So that's not too bad. But we still have to do that conversion. And so at Parizeau, we're actually not, this is not a SaaS product. So we're not serving this for our users. We're actually licensing it to other businesses. So other businesses, we have to go and help them integrate into their web applications. And we have to tell them, oh yeah, you have to convert this file. And yeah, it might take a while sometimes, so you can do these things to mitigate it. And some of our customers end up with a queue system to handle that. Some of our customers end up with a complicated caching system because they don't want to store all of these simplified files. And it's just a difficult conversation. So if we could simplify this, it would help our customers get started much more quickly and just be an easier overall conversation as well. So we did it. We used Emscripten to compile our C++ library to WebAssembly. And I mean, actually, we did this when ASM.js was just first out. And we used ASM.js, we used Pinnacle. So if they used Chrome, we would serve them Pinnacle. If they used anything else, we'd use ASM.js. Once WebAssembly came out, we switched everything to WebAssembly, except for browsers that don't support it, like IE. And yeah, we integrated into a web application. This eliminated all that server infrastructure. We don't have to, when we have our conversation with our clients, We don't have to talk about that anymore. We say, drop this HTML, JavaScript, CSS, WebAssembly, drop it on your static file server, you're good to go. Write some JavaScript code to connect to it. You don't have to worry about the scaling. So here's the simple example. Again, just what we've seen before. We're sending down HTML, JavaScript, CSS, WebAssembly, and now the client's doing all the work. We don't have to go back to the server. In this case, I mean, we're requesting a PDF maybe from the server, but it's a static file. You could also get the PDF from the user's computer. So overall, we don't have to worry about those server scaling concerns. No more delays when we're converting those large files. We can start accessing them right away. We can simplify the security concerns, similar to that FFmpeg-Wasm example. You don't have to like upload and download the file just so you can do some processing on it. And you only need a static server to get started. So overall summary, so we're saving ourselves time and money, we're increasing our responsiveness for our users, and just reducing the security concerns, since we're not going back and forth. And overall, for the right types of applications, WebAssembly can be a big win and can help you move on to the path of infinite scaling for your own applications. Thank you.